Okay, now we have 2, 5, 10, 17, 26, 37. Okay? Now one pattern, and somebody immediately said, well, you just add odd numbers. Yeah, well, to be more specific, add consecutive odd numbers starting with 1. Or starting with, with 3. So we could say, okay, we're going to add 3. We're going to add 5. We're going to add 7. We're going to add 9. We're going to add 11, and so forth. Okay? And then, we could then add 13, and then we'd add 15, and then we're out of room on the board. But that's going to give us 50, and add 15 is going to give us 65. Okay, if you saw the pattern that way, that's great. Now, there's another pattern that most people didn't see and didn't think of, and of course I had no expectation that many people would think of it, but I think somebody actually did come up with this, that 1 squared is 1. If you add 1, you get 2. 2 squared plus 1 is 5. In other words, each of these numbers is 1 greater than a perfect square. Okay, perfect squares are 1, 4, 9, 16, 25, and 36. Now, if you're not used to looking at those numbers, and of course, if you've become too calculator dependent, you're unlikely to see that, but that's another way to look at the sequence. Yeah, and it gives you the same result. The next number would be 7 squared plus 1. Of course, the next number we would add, well, 7 squared plus 1 would be 50, wouldn't it? 7 squared being 49. So we get 7 squared plus 1, and this should be 8 squared plus 1, and by darn it is. Now this also shows you something about squares. If you start with the first square, which is 1, and add 3, you get 4, which is a square. Then you add the next odd number. You added 3, the next odd number is 5, you add that, you get 9, that's a square. Add 7, you get 16. We're going to actually see a picture of why that works. So if you see this pattern, now another way to see the pattern is not to look at it as 1 squared plus 1, 2 squared plus 1. Just consider the pattern 1, 4, 9, 16, 25, 36, the pattern of squares. If you think of that pattern, then you look at this pattern and see all these numbers are 1 bigger. Okay? The pattern of this sequence is 1 squared, 2 squared, 3 squared, and so forth, up to n squared and beyond. So the pattern of this is 1 squared plus 1, 2 squared plus 1. So there are many ways that you can perceive this pattern. The simplest is, okay, just look at the differences, just like we did up here, and that works, that's great. But also try to see how this is related to the pattern of squares. Okay? Now here I write down the same sequence and write it down a little better than I did here, but you see the pattern easily. Okay, now we went on with another exercise that actually turns out to be related to this. Okay, and what I did was I wrote down a dot. And I'm going to have to write these down because I've kind of obliterated everything that I did before. Then I write down this pattern of dots. It's called a lattice. A pattern of dots will be called a lattice. Okay, so here's one. Here's another. These are commas. And what would the next one be? Think through what the next one would be. Well, you'd have 4, and you'd have 4 this way, and then you'd fill the rest of it in some order or another, and there you'd have a lattice with 4 rows of 4 dots. And what would be next, what would be next, what would be next. Okay? Now, we're going to come back to this because how many dots do you have here? Well, I'll bet you know, it's 1. How many do we have here? Well, there's 4. You can count them, or you can multiply 2 by 2. How many here? Well, easier to multiply 3 by 3 in a row by 3 rows. That gives you 9. 4 in a row with 4 rows gives you 16, and so forth. So these lattices represent the squares. And of course, the lattices are in the shape of squares. So the name squares is related to this type of pattern. Now we'll continue in a minute and see how this pattern becomes, how this pattern emerges.